All right, so you guys, we're gonna get into inverses and determinants. So there's a couple stipulations around this. So first off, you should know that if, just look at the definition, if a is a non-zero real number and 1 over a, or a to the negative 1 power, is the multiplicative inverse, because when you multiply them together, they equal 1, we can see that if we do that, we will get an inverse matrix if we do this in the world of matrices. So, for instance, if you look at this key concept, it says, let A be an n by n matrix if there exists a B such that AB times BA equals I of n, then they're inverses of each other. The I of n is that identity matrix. That's that 1, 0, 0, 0, 1, 0, 0, 0, 1, etc. for whatever that is. This is a 3 by 3. So whatever n by n, that's what you're going to end up with. So what we're going to do first is we're going to go ahead and we need to just do an example. The way we show it is we go a times b, solve it, and then b times a. If both of them work and give you the identity matrix, which in this case it's a 2 by 2, which would be 1, 0, 0, 1, both times, then they are inverse matrices. So let's just go ahead and get into an example. Oops, because I think that's going to help you guys the most rather than me just talking and saying words that, are new to you. Okay, so a times b. So I'm going to cross out that b times a first. So negative 3, 2, negative 2, 1 times 1, negative 2, 2, negative 3. We're going to do that multiplication. So 3 times 1, sorry, negative 3 times 1, plus 2 times 2. We're just following that matrix. Now, next row, we've got 3 times negative 2. Sorry, negative 3. I did that again. Times negative 2 plus 2 times negative 3. And that covers our top. Now the bottom row, negative 2 times 1 plus 1 times 2. And then negative 2 times negative 2 plus 1 times negative 3. Now I just need to simplify. I'm just going to keep moving this over to the right-hand side. Let's see, we get negative 3 plus 4, that's 1. Negative 2 times 1 plus, that's negative 2 plus 2, that's 0. The top right row, that's 6 minus 6, that's 0. And then 4 plus a negative 3, that's 4 minus 3, 1. So that right there, a times b, did give us an identity matrix. We're not finished, we just need to go ahead and do b times a. And if that one also comes up with the identity matrix, then they are inverse matrices of each other. Let me make these boxes a little small. All right, I'm swapping them now because we're doing b times a, so 1, negative 2, 2, negative 3, negative 3, 2, negative 2, 1. So I'm doing 1 times a negative 3 first, plus negative 2 times negative 2. Then I'm doing 1 times 2, and negative 2 times 1. That's my top row. Then I do 2 times negative 3, plus negative 3 times negative 2. Then 2 times 2, and then negative 3 times 1. Simplifying that together, that's negative 3 plus 4, that gives me a 1. Now down below I've got negative 6 plus a 6, so that gives me 0. Then 2 times a negative 2, that's 0. And 4 times a negative 3, that's 1. And if you look, both of these give us the identity matrix. So yes, they are inverses. If you get anything but the identity matrix on either, they will not be inverses. So if it's actually good, you know, it could work that you are working on AB and you don't get the inverse matrix. You don't even have to go to BA because it has to go both ways.